Have you ever thought about how important indoor air quality is to each of us? And what factors threaten the quality? In Western countries, we spend on average more than 90% of our time indoors. Did you know that in indoor air, the concentrations of some pollutants, such as formaldehyde, are often 2 to 5 times higher than in typical outdoor air? Did you know that air pollution is the greatest environmental threat to health and a leading cause of non-communicable diseases, such as heart attacks or strokes? Or that there are 7 million premature deaths every year due to the combined effects of outdoor and household or air pollution? Did you know that no country in the world meets the WHO 2021 air quality guideline of 5 microgram per cubic meter for particulate matter 2.5? Children are more susceptible to the effects of air contaminants than adults, and they can be critically affected by exposure to various air pollutants. For example, there is substantial evidence that exposure to air pollution increases the risk of children for developing asthma, and that exposure to air pollution is associated with an increased risk of childhood leukemia. The importance of indoor air quality was first recognized a long time ago. In the 19th century, Florence Nightingale provided care to wounded and ill soldiers during the Crimean War and developed her environmental theory. According to the theory, the environmental factors which affect the restoration of a patient's health are fresh air, poor water, efficient drainage, cleanliness or sanitation, light or direct sunlight. Nightingale established the following 4 indoor environment guidelines, which are still important and should be considered in the design and use of buildings. Bring air into the building from outside the building. Open the windows and close the doors. Air temperature fluctuations are necessary for us to stay healthy. Light is essential for both health and recovery. The body and mind degenerate without sunlight. Let's go back in time about 25 years. How did I become an indoor air quality researcher? My interest in indoor air quality research began with my concerns about unhealthy exposure to tobacco smoke, industrial emissions, and moisture and mold damage. Other significant contributing factors were my motivating and inspiring supervisor, the opportunity to do a doctoral dissertation related to my work, and the possibility of gaining international research experience in the high-quality research group at the Queensland University of Technology. Do you know what the typical pollutants of concern are today? Typical pollutants of concern from indoor and outdoor sources include the following: combustion byproducts such as carbon monoxide, particulate matter, nitrogen dioxide, and tobacco smoke; biological agents such as molds; various volatile organic compounds from a variety of products and materials; ozone from some air cleaners and from outdoor air; pesticides, lead, and asbestos; substances of natural origin such as radon and pet dander. Factors affecting indoor air quality are, for example, the air exchange rate, occupants' behavior, outdoor climate, and weather conditions. Do you know how climate change may affect indoor air quality? Some effects of climate change are already very visible in some countries. In 2011, a catastrophic flood hit the city of Brisbane, Australia. I was in the middle of that event. Several people died, and a huge number of buildings were destroyed or damaged. A similar flood event occurred in the same area in February of this year. After the 2011 disaster, we were among the first researchers on the ground, and we published research including the impact of flood and post-flood cleaning on airborne microbiological and particle contamination in residential houses, and exposure to airborne fungi in Brisbane houses after the 2011 flood disaster. In 2020, during the heat wave, bushfires almost reached my apartment in Brisbane. They also surrounded me when I had meetings in Sydney. In both places, the particulate matter concentrations were alarmingly high, not only outdoors, but also in many indoor spaces. As a result of climate change, the ozone concentration in the outdoor air is rising, and this is also contributing to the increase in the ozone concentration in the indoor air. This figure shows the critical areas in Europe. For example, in northern Italy, ambient ozone levels are above the WHO guideline value of 100 microgram per cubic meter for ozone. In one of our studies, we found that WHO EU guideline for ozone were occasionally exceeded in many school and office buildings. More information is needed on how different building materials affect indoor air quality under different climatic conditions. In one of our studies, we investigated the effects of paints and moisture content on indoor air emissions from pinewood boards. In another study, we investigated the emissions of di-2-ethylhexyl phthalate-free polyvinyl chloride fluorine. More information is also needed on how disinfectants and cleaning chemicals affect indoor air quality. The use of disinfectants and cleaning chemicals increased during the COVID-19 pandemic, and the effect of their use on the microbiome and chemical exposure indoors are partly unknown. The chemicals may react with each other and with chemicals emitted from building materials and from different emission sources. In our Academy of Finland funded Clean School project, we use a multidisciplinary approach to discover safe cleaning procedures for school buildings that reduce the harmful chemical, particle, and microbial footprint. Together, we can do something significant. Through extensive international research networks and industry collaboration, we can conduct internationally significant research, meet future research challenges, and help to prevent and control threats to indoor air quality. An example of this international cooperation is our InChild Health project, which has just received a positive funding decision from the EU. InChild Health will integrate health, environmental, technical, and social sciences research to identify determinants for indoor air quality and evaluate their impact in environments occupied by school children. For those who are considering where to study, we welcome you to consider the master's program in building technology at Aalto School of Engineering.
Like the applied touch for the teaching and for the research, and that's something that really interested me and eventually turned me into a scientist myself. The collaboration between the stakeholders and with the industry is something that really excited me.
Those thinking of doing a master's or doctoral thesis or postdoctoral research are welcome to apply to join our research team. And we welcome all of you to cooperate with us to achieve high-quality indoor air. I would like to end my presentation with a quote from Albert Einstein. If we knew what it was we were doing, it would not be called research, would it? Thank you.